Hi, welcome to this series of videos on the preparation for your GMAT quantitative reasoning. So, the quantitative reasoning section has two types of questions. One is your problem solving and the other is a data sufficiency. Problem solving is your straightforward basic question with 5 options, out of which you have to select the one which suits the best. But data sufficiency question, you will have one question and two statements that give you some information, and your job is to check whether the information given is sufficient to answer the question or not, and you select your answer options based on that. So, if the statement 1 alone is sufficient but 2 alone is not sufficient, then you will select the option of option A. If statement 2 alone is sufficient but 1 alone is not sufficient, you will select it as answer as option B. And if both the statements together are sufficient but neither statement alone is sufficient, then your answer becomes answer option C. And option D says each statement alone is sufficient, and when the statements 1 and 2 together are also not sufficient, then your answer becomes option E. Let's look at this first question now. It's asking, is 7 to the power of x greater than 100? This is the question. Okay, first piece of information says 7 to the power of x plus 2 is greater than 9800. Okay, 7 to the power of x plus 2 is nothing but 7 to the power of x into 7 to the power of 2. So, the statement is giving us that 7 to the power of x into 7 to the power of 2, which is equals to 49, it is greater than 9800. So, when you divide both sides by 7 to the power of 2 here, you will get 7 to the power of x is greater than 9800 divided by 49. 49 2s are 98 and 0. So, 7 to the power of x is greater than 200, which is greater than 100. So, yes, we can definitely answer the question. 7 to the power of x is greater than 100. So, therefore, this piece of information is sufficient. When you look at the second statement here, you have 7 to the power of 2x is greater than 10,000. You have 4 zeros. So, this means that 7 to the power of 2x is greater than 10 to the power of 4. By taking square root on both sides, you will have 7 to the power of x is greater than 10 to the power of 2, that is nothing but 100. Therefore, you can clearly that 7 to the power of x is greater than 100. Therefore, this is also sufficient. When both statements alone are sufficient, the answer becomes option D. Option D, where each statement alone is sufficient. Now, let us look at this next question. A and B are integers. Is a to the power of 5 less than 4 to the power of b? So, they are asking if a to the power of 5 is less than 4 to the power of b. First statement says a to the power of 3 is equals to minus 27, which means that a is equals to minus 3, because 27 is 3 cube. So, here we look at the statement, you have a to the power of 5 on one side. So, minus 3 to the power of 5, a is minus 3. Is it less than 4 power b? Yes, we can say yes, because this becomes a negative value, and no matter what the value of b is, whatever integer it is a negative, positive or 0, this 4 raised to any integer will always be a positive value. So, a positive value is always greater than a negative value. Therefore, we can say that yes, a to the power of 5 is less than 4 to the power of b. We can say this definitely. Therefore, it is sufficient. Now, let us look at the second piece of information. We have b square is equals to 16, which means that b is either 4 or b is equals to minus 4. Therefore, can we say that a to the power of 5 is less than 4 to the power of b? No, we cannot, because b can be either 4 or minus 4, and we know nothing about a. We do not know whether it is positive or whether it is negative or it is 0. So, out of these possibilities, we cannot define whether or not a to the power of 5 is less than 4 to the power of b. Therefore, this is not sufficient. Therefore, answer is answer option A, where statement 1 is sufficient but statement 2 is not sufficient. Let's move to the next question now. X and y are non-negative integers. Is x greater than y? You have the first statement here says 5 to the power of x into 3 to the power of y is equals to 9. 9 is nothing but 1 into 3 to the power of 2. 3 square is 9 and 5 which can be written as 5 to the power of 0 into 3 square. 5 to the power of 0 is 1. Therefore, x is equals to 0. Equating these both, you have y is equals to 2. Therefore, you can definitely say that yes, x is not greater, it is lesser than y. So, therefore, x we can definitely say that no, x is not equal to, x is not greater than y. Therefore, this is sufficient. Now, let us look at the second statement. 3 to the power of x divided by 4 to the power of y is greater than 4 to the power of y divided by 3 to the power of y. Since these are positive integers raised to other unknown integers, so we can definitely cross multiply. That is, we can say that 3 to the power of x into 3 to the power of y is 4 to the power of y into 4 to the power of y. Since they are all positive, no matter what power you raise them to, negative, positive or 0, these will always be positive values. Therefore, cross multiplying, you do not need to change the symbol of the inequality. So, here you have 3 to the power of x plus y is greater than 4 to the power of 2y. 4 to the power of 2y will always be greater than 3 to the power of 2y, as 3 is a smaller integer compared to 4 when you are raising it to the same power. So, therefore, this statement can be written as 3 to the power of x plus y is greater than 3 to the power of 2y, which also implies that x plus y has to be greater. When bases are equal, the powers should match the inequality. X plus y is greater than 2 to the power of y. So, x is taking y, subtracting y, on both sides you have x is greater than y. So, your answer is yes. Therefore, you can definitely say that yes, x is greater than y. Therefore, this is sufficient to answer the question. When each statement alone by itself is sufficient, the answer becomes option D. Let us look at the next question. 2 to the power of x into 5 to the power of n is equals to t. They are asking what is the value of t. First statement says x is equals to n plus 3. So, we will have 2 to the power of n plus 3 into 5 to the power of n is equals to t, but we still do not know what n is. So, therefore, you cannot answer the question and it means that this information is not sufficient. Let us look at the second piece of information, that is 2 to the power of x is equals to 32, which means that 2 to the power of x is equals to 2 power 32 is 2 raised to 5. So, x is equals to 5, but we still do not know in this, to find the value of t, you need to know what x is, plus you should also know what n is. So, we do not know what n is, therefore, it is not sufficient on its own. So, when you take statements 1 and 2 both together, you have x is equals to 5, x is equals to 5 and x is equals to n plus 3. So, 5 is n plus 3, so n comes out to be 2. Therefore, t is equals to 2 raised to 5, that is 32, into 5 raised to 2, that is 25. Therefore, it is sufficient to answer the question. Statements 1 and 2 together are sufficient to answer the question. Let us look at the next question. If x and y are integers, is x even? They are saying x plus y. Statement 1 says x plus y is equals to y to the power of 5. taking y to this side, you will have x is equals to y to the power of 5 minus y, which is y into y to the power of 4 minus 1. Okay, so let's consider the chance when y is odd. Odd number raised to any number will remain an odd integer. So this is odd minus 1, this becomes even. So it becomes y is odd plus into the second term becomes even when y is odd, and when y is even, you have even, this y is even into even raised to any power will give you an even number, then minus 1 of that number will give you an odd number, so that this will become odd. So x is always equals to, this is always equal to odd number into an even number, and that is always resulting in, which will always result in an even number. When you multiply an odd with an even number, the resultant is always an even number. So therefore this information is sufficient to answer the question. When you look at the second piece of information, x plus y is equals to 3y, which means that x is equals to 2y. 2 and x and y are both integers, so 2 into any integer will give you an even integer. So therefore this piece of information is also sufficient. Hence, therefore the answer is option D, where each statement alone is enough to answer the questions. Let's look at the next question now. For all integers n, the function f is defined by fn is equals to a to the power of n, where a is a constant. What is the value of f of 1? Okay, they are telling us that f of n is equals to a to the power of n, and we need to find what the value of f of 1 is. So the first piece of information, first statement says f of 2 is equals to 100, which means a to the power of n. A to the power of n is nothing but a to the power of 2 is equals to 100, that is 10 to the power of 2. When a square is equals to 10 square, either a is equals to 10 or a is equals to minus 10. So we cannot definitely say what f of 1 is. F of 1 will be equal to a. We cannot tell whether it is 10 or minus 10. So therefore this information is not sufficient to answer the question. Second piece of information says that f of 3 is minus 1000. So this means that a to the power of 3 is equals to minus 10 to the power of 3. This will definitely mean that a is equals to minus 10. A cannot be plus 10. Therefore f of 1 is equals to a is equals to minus 10. Therefore this piece of information is sufficient to answer the question. Hence the answer is option B, where statement 2 alone is sufficient but statement 1 alone is not sufficient to answer the question. Let's look at this next question. X square minus y square is equals to 1. What is the value of x? Okay, the first piece of first statement says x plus y is equals to half. We know that x square minus y square is equals to x plus y into x minus y, and it is given as 1. And x plus y is half. When you substitute that here, you have half into x minus y is equals to 1. So x minus y is equals to 2. These are the two pieces of information, which will be you have two unknowns and two equations, so you can easily solve what the value of x is. Therefore this is sufficient to answer the question. We don't need to actually do the calculations, we just need to see that whether or not information is sufficient to answer the question. Here we have two variables and two equations. It is sufficient to find the value of each of those two variables. Second statement says that y square is equals to 9 by 16. Then we can substitute this in the main information. X square minus y square is equals to 1, which means that x square minus 9 by 16, y square is 9 by 16 is equals to 1. Therefore x square is 1 plus 9 by 16, that is 25 by 16, plus under root 25 by 16 or minus under root of 25 by 16. It can either be 5 by 4 or minus 5 by 4. Therefore it is not sufficient. It's giving us two values instead of one definite value. Therefore the answer is option A, where statement 1 alone is sufficient to answer the questions. Those were some sample questions on data sufficiency for the topic of exponents. Hope they were clear. Thanks for watching.